guys, and welcome back to a new video. In this video, you will learn how you can use Ktor client as a networking library on Android in order to upload a file that we can pick from the user's file system together with a progress bar that just shows the current progress of that upload. So it will look like this. We have a button to select the file. We can select some kind of a PDF, whatever kind of file you want to upload. Click this, and then you will get this progress bar. And when the upload is done, we will get a little toast that tells us so. Just one last thing before we start with the video. Right now is the absolute last chance for you to get the new Coroutines and Flows Masterclass for a 30% discount, because in just a few hours from when this video goes online, the discount will expire. So it really doesn't matter if you want to prepare for an Android tech interview, if you just want to learn and master a very fundamental topic that is needed in any type of Android app. Click down below, use the discount code MASTERCLASS for 30% off before it will expire very soon. I've already pushed an initial branch you can clone from down below from my GitHub repository, in which I've included the necessary dependencies, or you just type these off when I show you these now. So on the one hand, we are using Ktor client, obviously, and we need the lifecycle compose dependency, so we can just easily create a view model with a constructor. So those are the two versions we need. We do have Ktor specific dependencies for the specific clients, for logging. We have the ViewModel compose dependency, and I've already created a bundle for all those Ktor specific dependencies. And then we can simply add this here to build.gradle app. So if we scroll down, you can see I added both those dependencies, and that's all we need in order to follow along. So if you want that, then clone this initial branch from down below, or just type these versions off, and then we can get started immediately. So let's think about what we actually need to do in which order in order to get to a fully uploaded file. On the one hand, we need a button, and when we click this button, we first of all need to open this file chooser. That works with the so-called activity result launcher. So we just launch another activity, so this file browser activity, for a result, which is the picked file. From that, we will get a so-called content URI, so kind of an identifier of where this picked file is located and from where we can read the actual bytes of it. That is what we'll need to do. So we'll need to take this returned content URI, read this in as a byte array, so we really know the contents of this picked file. And then we have to take this byte array and somehow attach it to our Ktor request to finally upload it on the server while we listen to the current progress of that. So let's start off going into our app module and creating a little file reader class. This will be used to take our content URI that's returned from this file browser activity, which we will then read in as a byte array in this class. So this will be a simple class. Yes, let me add that to Git. And we will need the context in here. So that's just something we need in order to read files or read a content URI in as a file. And this will then take a function URI to, let's call it file info, where we pass in our content URI, which is a normal Android.NET URI. And this will return a file info object. Not this one here. We will create our own wrapper class for that, which just contains the metadata, including the byte array of a specific file. Let's do this down here, class file info, which will be a class together with the file name. Let's just call it name, because the class name already reveals that we're dealing with a file, so we don't need to have that as the, we don't have to prepend that to the actual field names as well. We need the MIME type, so what type of file it is, because that's the information the server needs when we upload a file. And we, of course, need the bytes in form of a byte array. We're not using a data class here, because in that case, it would complain, because a byte array by default is not comparable with the equals function. We could generate equals in hash code here to make this comparable, but I'm not a big fan of that. You can see that looks quite complex, and you will always need to modify these two overridden functions if you change something about this class. So we just shouldn't use this to compare it all, which I think we can best communicate by just making this a normal class. So here in our URI2 file info function, we will take this URI first of all and read that in as a byte array. And we might actually make this a suspending function, so we can then return with context. We might want to pass the, let's call it IO dispatcher, which we want to inject and also pass in here. So IO dispatcher, which is a coroutine dispatcher. That is something that I would consider a best practice, because then you can also pass other dispatchers you might need for your specific use case for this class. So for example, if you would want to test this function that we're using here, then we want to use a special test dispatcher and not the real IO dispatcher. And if we inject this dispatcher here in the constructor, then for the test cases, we could inject the test dispatcher, and for our production code, the real IO dispatcher, which we could also pass as a default argument here, so we don't need to pass this from the outside. So with this IO dispatcher context, what we can then do is we can use our context.content resolver, which can be used to read bytes from a content URI. and we want to open an input stream based on our content URI. We can then check, okay, does that exist? Is there actually a file under that URI? And if so, we call use, which will open this input stream and automatically close it after use. So here we get this input stream, which we can then use to read these bytes. Depending on how loud this file is, you might want to read in these bytes here byte by byte, which this function doesn't do. It reads these in all at once. If we do it like this, we don't really support coroutine cancellation while reading this file. If it's a smaller file, then this is still fine because that's still fairly quick to read that in. But if your app supports reading in larger files as well, where reading that could take a moment, then you want to also make this coroutine, the suspend function here is running in, cancelable. And for that, you have to add frequent checks for cancellation. So you rather want to read in byte by byte in that case, in a while loop, where in every iteration you can then check, okay, is the coroutine canceled? And if so, jump out of that while loop. But all those are really concepts that I teach in detail in my Coroutines and Flows masterclass, which just launched. Also things like why we inject dispatchers in detail, or you can then use this to really test classes. So about all these things I dive into in much more detail in this masterclass. Here, I will include a link down below here. But for now, let's say we are fine with this simple setup. Since we then get our bytes here as a return value, let's also format that a bit more so it's more readable, like this. And if that for some reason does not exist, which should not happen in this case, let's just map this to an empty byte array. For our file name, I just want to generate a random file name. This really doesn't matter too much, since the server will probably have its own logic to store that file on that file system. And by just generating a random UUID, we make sure that we always have a unique file name. To get the MIME type of the file, so the actual file extension, we can use the content resolver as well and call getType to pass in our content URI and also just returning an empty string in case that does not exist, since in that case we don't have a MIME type. And then lastly, we can return our file info object here, passing in our file name, passing in the MIME type, and lastly passing in our byte array. So just as a little recap, this will be the function that we call after the user has picked an image from the file system, or just some kind of file, doesn't have to be an image of course, and we will then take this, read in the actual bytes, so we have the raw data of that file, and also construct a file name and MIME type, which we can then return, and we will then make use of this to finally upload these bytes to our remote server. Alright, so let's do that next. Let's construct something like a file repository here, which includes the function where we use Ktor, so an HTTP client, to take this file, to take these bytes and upload these to our remote backend. We create a class here where we will need an HTTP client, of course. So that comes from Ktor, which allows us to make network requests. We do need our file reader, which we've just created. And here we might also want to inject the IO dispatcher. And then here we can have a suspend function to upload a file. Upload file. We again pass in our content URI here from AndroidNet. And this will then return a flow, so from Kotlin Coroutines flow, and you will notice in a moment why we're using a flow to upload this file, a flow of progress info. That is how I will call this class, which we can create down here. So a data class progress info. Well, let's actually call it progress update. I think that's a bit more descriptive. Progress update here and here. And this will contain the information, how many bytes were already sent, and the total number of bytes, because with these two pieces of information, we can calculate the current progress ratio. So if half of the bytes have been sent, then we can divide this amount of bytes by the total number of bytes, and we get to 50%, which we can then use to update our progress bar in the UI later on. And we're using a flow because, well, this function to upload a file could possibly return or emit multiple values over a period of time. Because with every single progress update we get from Ktor, with every single piece of bytes that have been uploaded, we want to send such a new progress update from this repository to our ViewModel in the end, and then finally to our UI. And this flow can be constructed with a channel flow. So maybe you know a callback flow, which is very similar to a channel flow. But in the end, a channel flow just allows us to emit and send emissions, so progress updates in this case, from multiple different coroutine contexts, so from multiple different dispatchers, from multiple independent coroutines. And since a callback flow is usually used if we also want to perform some type of cleanup work, maybe to remove a specific callback, we convert to flow emissions. So in here in this channel flow below, what we can do is we first of all want to get the file info from our file reader. So we say file reader, URI to file info, and we pass in our content URI. And now with that file info, which is the our custom class we've created, which contains the file name, the MIME type, and the actual bytes. That of course contains everything we now need in order to take our HTTP client and upload these bytes to our remote server. For this video, I will use a demo backend for that, which is a public one. You can also just use to upload files. But of course, if you're working on a real app, then you would need to replace this data with your own custom backend. I think this should be clear. So we're going to use our HTTP client and call a function called submit form with binary data, because that's exactly what we need. So the typical way how file uploads work, that you will make either a post or a put request. So either to create a new resource on the server, which would be a post request, or to update an existing resource on the server, like updating an existing image, for example, with a new profile image, whatever kind of file you're uploading, then that would be a put request. That's something you have to take a look in your API documentation. But what post and put requests allow us is to create a so-called multi-part request. So just a request that consists of multiple parts and can also have single parts, which are a byte array. So here we want to use this overload that takes in a URL, where the URL is in this case equal to HTTPS DLP test. So that is the test website that I found online where we can test this upload, dlptest.com/HTTPS-post. And then as a next argument, we can attach form data. You can see that is a list of part data where each part makes up a single part of that request. So each part could be a single file, for example. And we can create this with form data, with this block here, where we can then construct all the individual parts, and we can add a part by saying append. So you can see we can append a form data part of some type of type. If you also wanted to attach some metadata, maybe some kind of JSON body or so, depending on your backend, of course, you could also attach so-called form items. So just simple strings. For example, imagine you have a social network app where you upload a profile picture again. Then you might not only want to upload a specific file, but also metadata to which profile this profile picture belongs to, for example. Then you could do it with a simple append function where you attach a key. So I don't know, user ID or whatever kind of backend you are having, and then you attach a certain value, which could be your JSON string. But this is of course something your backend server has to support. So here we could just say, okay, the file description is some kind of test string or so. Just that you understand that we can also attach these form items to this request. However, the interesting part here is if we use the key, the file, which the backend uses, to now not attach a specific string value, but our actual byte array. So the actual bytes of the file that we've picked. And we can get these with info.bytes. And for this specific file, we also want to attach metadata that the server needs, which is on one hand the file name and also the MIME type, which you can append with headers from here, headers that build from Ktor. On the one hand, we want to append the content type header. So HTTP headers dot, content type, which in this case is our info.MIME type, which we've read in before. And we also want to attach this so-called content disposition, which contains metadata about the file name. So here it needs to be in this exact format where we say file name is equal to, let's put this on a separate line so it's more readable, where the file name is equal to our info.name, so our actual file name that we've created before. And then as all the other HTTP client functions like making a post request, get request, as all these allow us, this function also allows us to have a body afterwards where we can further configure this request. So by default, a submit form with binary data will be a post request. If you would want to make a put request, you could do this with method and setting this to put, for example. In this case, we do want a post request, however. So this will already upload the file. But one thing it does not allow us to do at this point is, and that is listening to these progress updates. Currently, we have no way of listening to, okay, when was a new chunk of bytes actually sent to the server? And that is what we can do in this builder. By saying our onUpload function, that is the callback that triggers from Ktor, whenever there was a new chunk of bytes sent, where we get the bytes sent total and the total bytes, so all bytes that are about to be sent. And if this exists, so if total bytes is actually, let's say, is larger than 0L, then we call send, which is a function that comes from our channel flow and will now send and emit a new emission of progress update here in this channel flow, which you can then observe in our ViewModel. So we want to send a new progress update with our bytes sent total and our total bytes. And this is really how easily we can listen to these updates. So the next thing we need to do is we need to create a ViewModel, which just listens to these flow emissions, which lets us upload a file when we trigger this in the UI, then listen to these updates, and finally update our UI state so we actually see what's happening in our UI. So let's go to our root package and create an upload file ViewModel, which is a class. This will take in our repository or file repository. It will be a ViewModel reference. And we also need some sort of UI state. So just a class that represents the different fields that could change and have an impact on the UI. So we can say data class, upload state, where we have a Boolean, whether we are currently uploading or not, which is initially false. We have a Boolean, whether the upload is upload complete, which is also Boolean, initially false. We have a val progress fraction or progress, just progress will be fine, I think, which will be float initially 0. And we can have an optional error message, which is a nullable string. And then in here, we can construct a compose state, so our state by mutable state of with our upload state. Alt enter to import that. Alt enter import that again. Make it a private set, so only the ViewModel can really change this state, which is a best practice. And then we want to have a private var upload job. So this will be the reference to the coroutine job that will perform this upload. And I save this in a specific job reference, since then we can also add a button to cancel an ongoing upload. Because here in our upload file function we will create, where we pass in the content URI, we will then take this upload job and assign it to our repository. Upload file, we pass in the content URI, and we can then launch this here in our ViewModel scope. And I am noticing that upload file seems to be a suspend function, which it doesn't need to be, since just creating a flow with this flow builder doesn't need to be suspending. So we can just remove the suspend keyword here and everything will be fine. And then we can also call this function here in the ViewModel, launch this flow in ViewModel scope. So we actually start executing the functions here. So first of all, converting the URI to a file, then submitting that to our backend. But in between, after uploading this file or calling this function and launching this, in between has to happen something, because we want to also update our state based on the progress of this upload. And for that, we can make use of the so-called flow lifecycle operators, which we can use in here. On the one hand, there will be on start, for example, so when the flow starts being collected. In that case, we want to update our state with the state we want it to be when we start uploading the file. So we say state is equal to state.copy. Here we are now uploading the file, so we can set is uploading to true. Our is upload complete can be false, so we also reset these states when we trigger another upload. Our error message can be null again, so we reset that as well, and the progress will be 0f as well. Then the next function would be on each, so we listen to every single emission of this flow, which will be in this case every single progress update we send. We emit in this flow with a send function. For every single of these emissions, this on each block will now trigger. So we get the progress update, where we can say, okay, our state is now state.copy, and we update our progress fraction. And we can update it with progress update bytes sent divided by progress update total bytes. And we can convert this to a flow to actually get a decimal number. And that way, this progress state will be some kind of decimal number between 0 and 1f, which we can then use to update our progress indicator in the UI. Then after on each, what we want to do is we want to call that on completion. So when the flow completes, when the file has been uploaded in this case, then we might get an optional cause in here. So this cause will be a throwable, nullable, because a flow or a coroutine can complete for different reasons. In this case, the file was just uploaded successfully, but it can also complete and come to an end if it was cancelled. And in that case, this would be a cancellation exception. Or it could be some kind of other exception that was thrown in the flow, which would also make it complete. So if the cause is equal to null, if there is no cause, so if the flow just completed normally, if the upload was successful in that case, then we want to say state is state.copy, is uploading is false, and is upload complete is now true. However, else if our cause is a cancellation exception, then our flow was cancelled, which can happen thanks to the function we will write in a moment. So when this upload job will be cancelled, then the flow will therefore be cancelled since it's collected in this job. And then on completion will be called with a cancellation exception. And in that case, we can also update our state that we are not uploading anymore. So is uploading is false. And the error message can then be the upload was cancelled. Like this. And lastly, we would also like to catch certain exceptions that could be thrown during uploading, like if the user is not connected to the internet, if there are some other kind of errors, we can catch these with a catch operator, where we also get in a cause, which in this case is not nullable, since if we catch an exception, there has to be an exception, obviously. And based on this cause, we can then construct a little error message here. So val message is equal to when the cause is, for example, an out-of-memory error. That could happen if the file is very large. If you want to upload very large files, then this approach will probably not be ideal or not to be sufficient, because with the approach we have here, the whole file will be loaded in memory and then be uploaded from that point on. If you want to upload really large files, like multiple gigabytes large, then you of course don't want to load these multiple gigabytes into memory, since that would likely lead to this specific kind of error, but rather have a bit more complex solution, which reads in this byte in chunks, and while reading it, it will already upload these chunks and only resume reading when a chunk has been uploaded successfully. So that is what you would need to do if you were to also upload larger files. However, for most scenarios, this will be fine if you're just uploading a profile picture, if you're uploading a little PDF or so. So here in out-of-memory error, we just want to have an error message of file too large. If this is file not found exception, so if the file is not found, for example, then we also want to say this, file not found. If this is an unresolved address exception, for example, then this likely means there is no internet or the server is not reachable for some reason. And depending on what kind of other errors you want to handle here, you can of course extend this. I will just shorten this off with an else block to say, okay, something went wrong in case this is just some other kind of exception. We can then take this, update our state with is uploading being equal to false, and our error message being equal to the message we've parsed before. And this is now our flow. So I really like flows for these kinds of things. You can see how easy that is to listen to specific events, like when the flow starts, when there is an update, when it completes, to catch exceptions from that flow. And of course, you could also use that to transform it, I don't know, with the map operator to filter it for specific emissions. So flow is our really important topic on Android. You can see how cool that is and how easy it is to really listen to these updates. But that's really also something I dive into in detail in my new coroutines and flows masterclass. Let's go on down here and also provide a function to cancel the upload. So cancel upload. This will be super simple. Here we just say upload job.cancel. And since when we cancel this upload job, then the coroutine this flow will be collected in, will be canceled. It will throw a cancellation exception, which we can then react to here. And then we get this error message. We should also reset our state to the default state after canceling an upload. Or do we actually need to do that? I don't know, because we also reset this here, because there could be some kind of race condition when I think about it, so that this state update fires before this state update. So let's just actually extend this here a bit, that if the upload is canceled, we say the error message, oh, I actually already said that. I mean, the is upload complete boolean would be false, and the progress would be set to 0f again, and then we don't need this, we don't need to reset the state down here. So the last two things we now need to do is we need to set up our little sample UI, which uses this ViewModel and also triggers this upload file function, and we need to construct a very basic HTTP client reference, so we can also construct all these classes here, like the file repository, the reader, and so on. So let's go to main activity, and in here we want to create our ViewModel, which we can do with the ViewModel function here, which we get from our dependency we've added earlier. And here we can then construct our upload file ViewModel, where we pass in our repository. So file repository. Of course, in a real project, I would have a proper dependency injection set up and not create the ViewModel like this in the UI. But let's keep it simple in this case, and since that's really not the topic of this video. Let's construct an HTTP client. Well, we don't have that yet. Let's leave this blank for now. But the file reader is something we can already create, with file reader, context being equal to our application context, and the dispatcher is already set to the IO dispatcher by default. For our HTTP client, we can create a little singleton in here. So HTTP client like this, make this an object. And let's say we have a client by lazy, where we construct our HTTP client with the CIO engine, in which we can then configure this specific client. We could, for example, install the logging feature, so we can actually also understand what happens here. So this IO Ktor clients plugins logging, where the level is equal to log level that all. So we want to log everything, and the logger can be logger.android, for example. And that should already be enough for this HTTP client in regards to constructing it. So we can refer to it here with HTTP client, this time from our own package, that client. Then below, what we'll need is a file picker launcher. So the activity result launcher I've mentioned before, which we can get a reference to with remember launcher for activity result, where the contract is activity result contracts dot get content. So we want to pick a specific piece of content, so a specific file in this case, where we then get the content URI here once the user picked the file. If that content URI exists, so we make a null check, then we want to call our ViewModel.upload file with that content URI. And then down here, we can have our actual UI where we display the progress. So let's first of all have a box. So we center all the content in it with a modifier. We give it a fill max size modifier, and we apply this inner padding from our scaffold. So we consider the status bar padding, and we also want to say content alignment is center. All right, in here we want to have a when expression, because depending on the state we get from the ViewModel, by the way, so val state is ViewModel.state. If our state is not uploading, so if we're not currently uploading a file, then that means we want to show this as a button to pick another file. So here, let's have a text, actually a button with a text. Text can say pick a file. And when we click this button, then we want to use our pick file launcher, pick a file picker launcher. That launch, and the input here is a string, so that is the MIME type of the files that we want to be able to pick. In this case, we want to allow any type of file, so any specific file type. So we can say asterisk / asterisk, and with that, we consider all MIME types. Then we have an else block. So this means there is currently an ongoing upload. In this else block, we can construct a column, since here we now want to show the progress indicator together with a button to cancel the upload. Modifier can be modifier fill max size. Well, actually, no, we already center this column's content thanks to our box. So let's just center everything horizontally here. So horizontal alignment is alignment center horizontally. Inside, we will then have a linear progress indicator. So this will be our progress bar composable, which takes in a lambda for our progress, which we get from our state. So state.progress. We can assign a modifier that padding 16 dp. Alt enter to import that. We make it fill our whole width. And we might also give it a height of, 16 dp. However large you want this progress indicator, progress bar to be. Below, we can then have a text that says, contains the actual progress fraction, where we say, okay, state.progress %. And we can also multiply this by 100, put this in parentheses, so we can convert this or round this to an integer value. And lastly, as I've said, we have a button, and when we click it, we cancel the upload. So ViewModel, cancel upload, and the text will be cancel upload. I think that should be it. We of course also need internet permission, so let's go to our manifest. Up here, say users permission internet. And then I would say this is ready to be tried out. Let's launch this on our device. There we go. We can pick a file. Let's do that. We pick our file example. And you can see we do get that upload progress. Very cool. We're not yet showing any toast depending on our state. That's something we can still do, of course. Here, for example, so we can react to these state changes with a launched effect by saying state error message, for example. So when that error message exists, we can show a toast with it. Toast.make text, pass in the application context, pass in our error message, and pass in toast.length long to finally call show. The same thing we can do with when the upload is complete. So here, state is upload complete when that changes, and the upload is complete. So if state is upload complete, then we want to show the toast. This can be removed down here, and this would then be upload complete. So if we now relaunch this, then check in here, we pick a file, this one, then after the upload is complete, we do get our upload complete pop-up. If we cancel the upload, there's still something we have to test. So let's do this again. Cancel. The upload was canceled. As you can see, we instantly see our pick a file button again. A little hack to enhance this, to make this look a bit more smooth in your UI, if you maybe don't get that many upload progress updates, is that we can animate the progress indicator, which we currently don't do, and it will still look very smoothly, as you've seen, if we have a stable internet connection, if there are lots of these progress updates coming. But we could, of course, also animate the transition from one progress to another progress. And we could do this with val animated progress, setting this equal to animate float as state. We pass in a target value, which is our state progress. We can pass in an animation spec, like a tween, for example, set the duration millis to 100 milliseconds, and giving this a label for the preview of something like file upload progress bar. So with animate float as state, this will pretty much just animate state changes when a certain state, the target value changes. So if this is 0.1f, for example, so at 10%, and the next update would be 30%, then the animate float as state will animate the transition from 10% to 30% in 100 milliseconds, so it looks more smoothly. So we can then take this animated progress. I think we can also use the delegate here. So by and Alt-Enter to import this, yes. And then it's really just a float. We can then use in here, animated progress, launch this again, test this one last time. There we go, we can pick a file, our PDF, and now looks exactly as smooth as before, but depending on your use case, depending on the amount of updates you are getting, this might make it more smooth. Cool, I hope you enjoyed this. If you want to learn more about coroutines and flows, as I said, down below, you will find the link to my new masterclass about these topics with more than 45 videos just about coroutines and flows. Thanks so much for watching. I will see you back in the next video. Have an amazing rest of your week. Bye-bye.